In this exercise, I'll show you how to configure GRE. First of all, GRE is a tunneling protocol developed by Cisco, and the main difference between GRE and IPsec is that in GRE, the main goal is not encryption, but encapsulation. You might wonder, what's the point then? Well, sometimes you need to send non-IP packets via an IP network, and in those situations, GRE is very useful. I skipped mentioning the full name. GRE is short for Generic Routing Encapsulation, and that actually explains it pretty well. Again, we have a packet tracer file for you. You'll notice that it's the same topology we've used for IPsec. So hopefully you're already familiar with it and we can get right into it. I'm going to start from router 1. And right away, I'm going to create a tunnel interface. I'm going to say IP address 10.0.0.1.255.255.255.0. That's this subnet right here that I assigned to the tunnel. Then we're going to say tunnel source serial 000. This is telling the router to encapsulate with GRE all the packets whose source is serial 000, which actually means that originally it wouldn't send these packets coming from this LAN through the tunnel, but we will force that to happen later. You'll see how. And then tunnel destination 10.2.2.1. Again, that's that interface on router 3. Then I'm going to say tunnel mode GRE IP, and then I'm going to add a route to make sure that the packets coming from this network and going to this network are also encapsulated by GRE. So I'm going to say IP route 192.168.3.0. This is a typical IP route. I'm telling it where a destination is, or through which interface, in this case, to send certain packets. So the packets that will be sent from here to here, and then also I need the mask. We want those packets to go through the tunnel. So what I'm going to do is I'm going to tell this router that the next hop is the GRE tunnel IP address that I'm about to assign to router 3. Here I assigned 10.0.0.1, and here I'm going to assign 10.0.0.2, so that's what I'm going to say, 10.0.0.2. Moving on to router 3. Enable configure terminal, interface tunnel 0. IP address 10.0.0.2.255.255.255.0. And then tunnel source serial 001, and then tunnel destination 10.1.1.1, and then tunnel mode GRE IP. And now all I'm missing is that IP route that I also added on router 1. This time it's going to be IP route 192.168.1.0, 255.255.255.0, and then 10.0.0.1, because this is tunnel IP of router 1. It's time for testing, so let's try a ping from router 1 to router 3, because this one is going to for sure be encapsulated by GRE. You'll see that the router realizes that right away, and then when the packet reaches router 2, we will also be able to see some GRE headers right here. Now the moment of truth. Let's see if communication between A and C works. We want to check in simulation mode if the packet goes through the GRE tunnel or not. Yep, the packet received on tunnel 1 and needs to be encapsulated in GRE. The packet received is encapsulated in GRE. The device encapsulates the data into an IP packet, and then inbound PDU is not going to have any trace of GRE, but outbound PDU is going to have a GRE header. I encourage you to open the routers and check the routes that I added into this file or exercise, whatever you want to call it, just to make sure you understand how it's configured, because they're all static routes. You could have a protocol as well, but then you need to make sure that these static routes are better than the routing protocol routes, but they usually are by default. So yeah, it would be nice to continue to play with that a bit more. That's it for this exercise and probably the entire course. Hope you found it useful, and see you soon in some other course.